We're writing radicals using rational exponents. So a radical is your square root symbol. That's your radical, or your radicand. You'll hear this as, you might hear me say like, this is the square root of 3, or radical 3, or rad 3. So take a look at the little recall. So remember, 3 squared is 3 times 3. 3 cubed is 3 times 3 times 3. It's just repeated multiplication. But what does 3 to the 1/2 power mean? We cannot use repeated multiplication, but how do you multiply 3 by itself half times? So we are going to write this. 3 to the 1/2 power is the square root of 3. And that's just read as the square root of 3. The 2 is implied, so you don't see it, but it's tucked in right there. That's right there. Just like you don't write an exponent when you just have like the number 4, you don't write down 4 to the 1st power, it's just 4. It's implied. That 2 is implied there. So 2 to the 1/3 power, the 2 is the base, and the 3 gets tucked in there, and then the 1, which is the numerator in that 1/3, it would be there, but we don't usually write it. You're just gonna write it without. The cube root of 8 to the 4th power, I had a formatting issue, which is why you see that extra space there, but this is just written as the cube root of 8 to the 4th power. If you look at the pattern of how we have written things, that's your base, and it's going to be to the 4/3 power. So you will see that the root is going to be your denominator, and it's 8 to the 4th power. So now we're going to use the product of powers property to solve equations. So we have 2 raised to the x3rd power. I'm just going to write this out a little bit bigger. Okay, multiplied by 2 to the x to the 3rd power is 2 to the 4th power. So if you notice, all the bases are the same. So we have, these are all the same. So in a sense, we can just ignore these bases, get rid of them, and if you remember our product of powers, when the bases are the same, you just add those exponents, so we can add these, and it will equal the other exponent. So we have x over 3 plus x over 3 is 4. These are just like adding fractions. So you have common denominator. You have 1x, there's one that you don't see there, plus another 1x gives you 2x over 3 is 4. And then we just have to solve for x by multiplying both sides by 3. We have 2x equals 12. Divide both sides by 12. You have x equals 6. Let's take a look at the next one. So I'm going to write this a little bit bigger. We have 3 okay, so we have bases that are the same, so we can get rid of the bases and just deal with these exponents. We have x over 2. Remember, we can add them now. X over 6 equals 8. So now the 2 and the 6 are not the same. So we need to come up with a common denominator, and that is 6. So if you remember, 2 goes into 6, we multiplied by 3. So we need to multiply the x by 3. We get 3x. And then 6, this is just going to stay the same. That's going to equal 8. So 3x plus 1x is 4x over 6 is 8. You can simplify, or you can just go ahead and multiply by that denominator. We have 4x equals 48. Divide both sides by 4, and you have x is 12. All of these are checkable. So I'm going to go back to this one here with x is 6. And I'm just going to take that 6 and I'm going to put it right in here. Okay? So we have 2 raised to the 6/3 power, which is just 2 squared. Multiplied by another 2 squared, and that's going to give you 2 to the 4th. Which it does. Keep the bases, add the exponents, you get 2 to the 4th. Or if you simplified this whole thing, 2 to the 4th is 4. 2 to the 4th is 4, and then, 2 squared is 4, and then 2 to the 4th is 16, and this does make a true statement. So you can go ahead and check all your work and see. Let's go ahead and try the same thing with x is 12. You put it here. 12 divided by 2 is 6. You end up with 3 to the 6. 12 divided by 6 is 2. You have 3 squared. And 6 and 2 gives you the 8. This was the classwork and homework that we had. It was page 221, 7, 9, 10, 12, and then 13 and 14. Number 13, down at the bottom, the answer kind of got cut off. You just left it as 80 over 7. You don't have to turn it into a decimal. You can leave it. Okay, so what happens if the bases are not the same? Where we have base 2 and we have a base 8, and we need to switch that base 8 to make it a base 2. So 2 to what power is going to give us an 8? And so that new exponent would have to be a 3. So now we have the same bases. We have a base 2 and a base 2. This one's just raised to the 3rd power. If we had 16, we had a 2. What are we going to raise that 2? We need a new power, so that it's going to be 4. If we had a 32, that 2 is going to be a 5. If we had a 12, oh, we can't do anything with that. So there's no power that we can raise the 2 to get us 12. So that one's just not going to work. If we had a base 4, so if you have 16, you will need it to change it to 4 squared. 64 would be 4 cubed. 20. Nope, not going to happen. So when we're working with these next couple of problems, this is what it's going to look like. We are going to have 64 raised to the x plus 1 power is going to be equaling 4 raised to the x plus 7 power. So we need to rewrite the 64 as a base of 4, and look at that coincidence, raised to the 3rd power. So when we do that, if you notice right here, that's raised to the 3rd power, we are going to have to multiply that whole thing by the x plus 1. Just make that a little neater. Okay, now we have the same bases. So we can ignore that, those bases. So now we have 3 times x plus 1 equals x plus 7. Distributive power, 3x plus 3 is x plus 7. And I like to move the variables first so I don't worry about any negatives. 2x plus 3, oops, change colors, equals 7. 2x equals 4, and x equals 2. And this is checkable. When we did this in class, we were happily surprised to see that when you take that 2, put it in up here, you end up with 64 to the third power. And then when you put that here, you end up with 4 to the ninth power. Go ahead and input this into the calculator. We were a little nervous because these exponents were, one's a 3, one's a 9, and the bases are, different quantities, but it does work. So check it out on your calculator and see what happens. The last example we did in class, we had 16 raised to the x minus 3 equals 2 to the x minus 6. You'll notice in some of these, like the first one, there were no parentheses around the initial exponents. Here you see that there are. Some there will be parentheses around one and not the other. It doesn't matter. It's still going to be done the same way. So now we are going to have to rename 16 as a base of 2. It's going to be a power of 4. So we have 4 x minus 3 equals x minus 6. We have 4x minus 12. Don't forget that this is 4 groups of x minus 3. 1, 2, 3, 4. And that's where you're getting your 4x minus 12, is because you have these groups. And you can also think about the distributive property, 4 times x, 4 times 3, you have your 12. So I'm going to subtract x because I want to get the x's on the left-hand side. Add 12. 3x is 6. Divide by 3. X is 2. This last problem looked a little intimidating because of the fraction, but it's not so bad. Class actually thought it was fun. That's a 216 raised to the x plus 1. Now in this case, you have to change both. So what we did is we looked on the board at the perfect squares and perfect cubes, and we noticed that 36 is 6 squared, and 216 is 6 cubed. So I'm going to leave this to you to finish up, and hopefully you're going to be all caught up when you get back.